All right, it's been a while, but we're back for Chapter 7, Section 1 and 7-2. We're going to start with a quick warm-up. 2 to the 5th is where you multiply two fives. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Why does that say a 6? All right, this is -4 multiplied by itself again. So -4 times -4 is positive 16, times -4 is negative 64. This next one, it should read like that. I'm not sure how it got scrunchbled. But what this means is the negative is out front and then 2 is squared. So the answer is actually -4. The negative is not squared. If the negative was to be squared, it would look like that, and then that would yield positive 4. 0 to the 6 is just 0 times itself 6 times, and 0 times anything is 0. 12 to the 0, anything to the 0 is 1. Another way to think about this is 1 times no 12s. So 1 doesn't change anything. So 1 is your answer. 5 to the -3. Now this is a little weird. If you think about a table, 5 to the 0 is 1. 5 to the 1 is 5. 5 to the 2 is 25. 5 to the 3 is 125. Now if you go backwards, going forward, you're multiplying by 5. So going backwards, you would divide by 5. So 5 to the -1 is 1/5. 5 to the -2 is 1/25. So 5 to the -3 would be 1 over 125. It's the same thing as 1 over 5 to the +3. You can move an exponent to the opposite side of a fraction, and it will become positive. Okay. So we're going to talk about exponents. And if we continue on then, 3 to the 0 is 1. And then we have 1/3. And then 1 over 3 squared, which is 1/9. And then 1 over 3 cubed, which is 1/27. And then 1 over 3 to the 4th, which is 1 over 81. And it is better to put these in fraction form than decimal. The decimal would yield a rounding error. So anything to the 0 power is 1. No matter what it is. Basically it means there's none of them, but we can do 1 times and nothing changes. And that's how we're getting that 1. And then the rule for negative exponents is basically you can move it to the opposite side of the fraction and it becomes positive. So 5 to the -3 is 1 over 5 cubed, which is 1 over 125. That's the one we did on the first page. -8 to the -2 is 1 over -8 to the +2. The negative in front of the 8 doesn't change. It's the exponent that's changing when you move it. So this would be 1 over 64. And 2 to the -5th would be 1 over 2 to the +5th. And remember, 2 to the 5th is 32, not 36. So order of operations, please excuse my dear Aunt Sally, says you do exponents before you multiply. So we would simplify this first. So 5 times 1/9, because that'd be 1 over 3 squared. So this answer would be 5/9. In the next one, the best way to write this is actually to just put the W to the +4th in the denominator, and then we don't have negative exponents to deal with. So x to the 0 in this last one is just 1. We don't even really need to worry about that. So we could simplify that to be 6 over y cubed. You could leave the x to the 0 in there. It doesn't do anything. It just makes it 1. So when the negative exponent's in the denominator, we can move the whole thing up and it becomes positive. So this is 5 times 2 to the positive 3. 2 to the positive 3 is 8. So this is 5 times 8. So our answer is 40. All right, we're going to get rid of the a to the 0 because anything to the 0 power is 1. We're going to move this up and make it positive. And we're going to move this down and make it positive. So we have a c cubed on top. Then on the bottom we have a b squared and a d to the 6. So if we start right here with 10 to the 0, we know we have 1. 10 to the 1 is 10, and this is actually kind of backwards for my brain. Usually the smallest is over here, but we'll just keep cruising with this. 10 squared is 100. 10 cubed is 1,000. 10 to the 4th is a 1 with 4 zeros. That's 10,000. And 10 to the 5th is a 1 with 5 zeros. That's 100,000. Now, 10 to the negative 1 is 1 over 10, and we can simplify this by writing it as 0.1. And we're going to because we're going to move into scientific notation, which is decimals. So the next 10 to the negative 2 is 1 over 100, which is 0.01. 10 to the negative 3 is 1 over 1,000, which is 0.001. And 10 to the negative 4 is 1 over 10,000, which is 0.0001. So basically, when you have this negative 4, you are moving the decimal 4 back. So if you have 1, you take this decimal and you move it 4 back. So that's how we get 0, 0, 0, 1. We can also divide that out to get it. So exponential notation is like 10 to what power? So this is our exponential notation. And this is our actual answer. So if we're going to do a power of 10, that's a base of 10. So this would be 10 to the, how many zeros are there? 10, because there's 10 zeros. And this time we have moved it 1, 2, 3, 4, 5, 6, 7 spaces back. So this is 10 to the negative 7. And this time we have 6 zeros, so 10 to the 6. And you can always test these in a calculator if you're feeling confused. So scientific notation is a number between 1 and 9.999. So this is actually not even proper scientific notation. None of these are. We'll go ahead and multiply these out, but I just want to make sure you understand this is not proper scientific notation. So if we're doing 10 to the 9th, we're going to move this. I'm going to write 23.89. We're going to move this 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the 9th is a big number, so we're going to be getting an even bigger number. 4, 5, 6, 7 zeros. So our 8, 9 counts for 2 of our spaces, and then we have 7 zeros. So 23 billion, 89 million would be our answer. So proper scientific notation would actually be making that a 2.389. And if we did that, we would have to multiply it by 10 to the 10th to get that same answer, because that 9 means we move it 9 spaces. So if we put it here, we'd have to move it another space. So this is proper scientific notation, how this should be written. And then, this is all shrunk again. This should be 10 to the 5th like that. So we're going to take this decimal and move it 5 spaces to the right to the bigger, because we're multiplying by this number. So we're going to get a bigger answer. So this is going to be 450. We don't really need these first two. If I put 0, 0 here, that doesn't make a ton of sense. So you're going to want to get rid of that piece of it. So 450 is your answer. And then 10 to the negative 6, we're going to take this decimal and move it 6 back. So your answer would be 12. And if you want to write that in proper scientific notation, it would be 1.2 times 10 to the 1. And if you want to write the one before in proper scientific notation, it would be 4.5 times 10 to the 2. All right, so this explains that it has to be a number between 1 and 9.9. So the first one will not work. It would have to be right there. The second one will. This one will not. It would have to be right there. This one will. And this one will work. So those would work to be the coefficient of scientific notation. So if we want to convert these into proper scientific notation, we would have to move this back 3. So it would be 4.673534 times 10 to the 3rd. So the number I wrote in the bottom is in proper scientific notation. The number above it is called standard form, the answer. So this decimal would have to be moved 4 over. So your proper scientific notation is 5.63 times 10 to the negative 4. This would have to be moved 1 back. So 3.4981 times 10 to the 1. That would give us the black stuff above. Okay, we've moved 8 spaces. 3 times 10 to the negative 8. If you put that blue stuff in a calculator, you will get the answer above. And this you're going to be moving 2 back. So 10 to the 2. So when you're multiplying by a positive exponent, you're getting a bigger answer. When you're multiplying by a negative exponent, you are getting a smaller answer. So 10 to the 4th is quite large. That's a 1 with 4 zeros. 10 to the negative 12th is 11 zeros and then a 1. That accounts for 12 spaces. So that's a very small number. If you multiply something by 10 to the negative 12th, you're going to get a very small answer. So this first one is going to be a large number. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 billion. This is going to be a super small number. We probably don't have to go move this back 18 spaces and write that. This is going to be even smaller, because we're moving back 23 spaces. Okay, so if we want this in scientific notation, we would take this decimal and move it 7 spaces back. So 5.8 times 10 to the 7th. We're multiplying by 10 to the 7th because we have a bigger number initially. Okay, that's where my scientific notation dot goes. It's 10 spaces. So this first number is a number between 1 and 9.9, and then times 10 to the 10th. These 10 spaces is that 10 right there. So if I'm looking at this now, if this is 10 to the 10, that would be a huge number. So this 10 needs to be negative because that number is a very small number. So it gets a little confusing if you're thinking about moving right or left because it's kind of opposite of if you're solving it or if you're looking at it and converting it. Depending on which way you go, it's tricky. So it makes more sense if you make it make sense. This means it's going to be a small number, so that's why it has to be the negative. This is a big number. So when we are writing the 10 to the power, we're moving it 9 spaces. Now we have our number between 1 and 9.9, and it's going to be a 10 to the positive 9. So now we're going to write these in standard form. So we're going to move this decimal 4 to the right because we're given scientific notation writing the number out. This is going to be a bigger number because we're multiplying by a big number. So 56,000. This we're multiplying by a big number. We're going to get a bigger number. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 8 zeros there. So 3, 4, 4, 3, 4. We've got million, billion, 3 trillion. 443 billion, 4 million numbers. All right, 10 to the negative 6 means this is going to get smaller. We're multiplying by a small number. So we're moving backwards. So that's your small number. And that's we're moving back to. So 0.03 would be your answer. So instead of thinking if you move right or left, you want to think, is the number bigger or smaller? And then when you have your scientific notation, all of these are proper scientific notation because that number in the front before the 10 to the power is a number between 1 and 9.9. The minute you have a 10, you can change the 10 power and make it proper scientific notation. All right, hope that makes sense. I will see you all tomorrow.